All right, so issuing convective warnings with WSR-88D outages, an interesting and relevant topic, and so that whole presentation and then follow-up discussion will be managed by Phil Schumacher from Sioux Falls. Phil.
Thanks, Kim. First of all, I want to really make sure everyone knows there's two things about this case. First of all, the AWIPS did work during this case, so the warnings were not issued without an AWIPS. And the second thing, which will be pretty evident pretty quickly, is this is not the Sioux Falls CWA. This is going to be out of Omaha. It's actually a case I was working that night. I was watching their radar and the satellite from this night. So this is really just a proof of concept to see if we can do this. And actually, it's kind of happened in North Dakota earlier this summer, where the radar, Bismarck lost comms for a bit, was unable to send out radar data. So basically, Grand Forks was issuing warnings without radar, although they had phone conversations with Bismarck at the time. So it can happen, and as our radars get older and they get retrofitted, this could happen to any of us at some time. So what I want to do is just start off first with the SPC outlook. This is the 1630 outlook. So we're going to start out in mid-afternoon just before the 20Z outlook comes out. You can see a really nice there's an enhanced risk for much of eastern Nebraska, southwestern Iowa, into Kansas and Missouri. And when you look at it closely, what they're really focused on is the wind threat, a 30% wind, and a 30% hashed hail threat in that area. And so tornado threat is not expected to be a big concern here, only a 2% over eastern Nebraska. And we'll see in a little bit why that tornado threat is less than the wind and the hail threat as we go through the environment here. So Chad will bring up we're going to look at the RAP 13. This is going to be like the most rapid environmental analysis you may ever see, because we only have 5 minutes, or 5 to 10 minutes to go through it. But we're going to start here with MLK. This is the 20Z RAP. So if you look at that's at 17.
Oh yeah, thanks.
So what you can see here, the thing I want you to note is you can see that there's really decent instability, especially from I-80, which is about right here, the Omaha area, Lincoln, southward. And you have about 1,000 to 1,500 K farther to the north. But you can kind of see there's an obvious cold front sitting across central Nebraska, and then there's a fairly obvious warm front that moves east and northwest up towards the O'Neill area, Holt County, which is the big, huge county just west of the Omaha CWA, to the right. And so you kind of get a sense that there's there could be some sort of enhanced convergence there. And as we walk through time here, go to the 21Z, 22Z, notice that all this moisture and stability is moving north over time. So as if storms develop farther west and move east, and we'll look at bunkers motion in a little bit, they're going to move into an area where the atmosphere becomes increasingly unstable due to this increased southerly flow out ahead of it. You can see kids are up to 2,000 now, just south of Norfolk, and it's moved north of I-80 by 22Z. And if we go to 23Z quickly, you can see how it's really has destabilized, getting probably over 3,000 as far north as Omaha. The specific values don't matter that much. It's more the fact that you have this more unstable air moving northward at a time when you're expecting convective initiation. So the air mass, at least in terms of instability, is getting more favorable. If we go look at the 0 to 6 kilometer shear, off shear. Oh, that's it. Yeah, there we go. So when we look at this, we go back to 20Z second. You can see that, if you remember, our front is sitting out west of the CWA. Shear is generally on the order of 50 to 55 knots, all the way across much of northeastern Nebraska. So more than adequate shear for supercells to develop. In fact, even along the boundary, where we'd expect it, where the warm and cold front come together across the northwestern CWA, northwestern CWA. So one would expect that this is an environment that is at least favorable for supercells. And we throw up the 0 to 1 kilometer shear quickly here. see again where the front is. We have shear generally 10 to 15, maybe as high as 20 knots if we go forward a couple hours here. You see, you get close to 20 knots across northeastern Nebraska, definitely less as you move southward. So it's a pretty marginal tornado environment. The one thing you'd be concerned about is having a boundary there. Obviously, you can get locally enhanced salicity and shear. So if you get a supercell that is able to latch onto the boundary, especially along the warm front, that might be an enhanced tornado risk. So it's something from a missile analyst point of view, you want to really keep track of where that warm frontal boundary is over time, and where those zones are with respect to that boundary. But overall, this is not the environment you want for a widespread tornado outbreak. The shear is just a little bit lacking at low levels, great shear in the upper levels. So type of event where you'd expect large hail and damaging winds from supercells. So the next thing is since you have that in mind, the one thing you wonder is with a strong boundary across this area, how fast will these storms grow upscale? And one thing you could do is we could go look at the HER. So how we do this a little bit differently. We're going to look at the HER at specific hours. So we're going to start at this is verifying at 21Z, and we're going to look at 5 different hours of the HER to get a sense of what the HER is sure of and what the HER may not be so sure of. So we're going to put up the 1 kilometer reflectivity image and then the max updraft helicity. So if you look at 21Z here off the 15Z run, you can see it's pretty discrete cells, some supercells showing up on there. You got updraft helicities, I think, with the northern cell over 100 meters squared per second square at the time. And as we go to the 16Z run, you see the same thing, kind of supercells. You can see initially they're discrete. You can see that 16Z run's growing at upscale a little faster. Go to 17, again, supercell 18Z, 19. All pretty similar. They're all showing supercells forming over northeastern Nebraska, except for the 20Z run, which decided to back off on the timing. So the 20Z run doesn't. So you kind of get a sense, if you look at it, there's pretty good high confidence storms are going to develop sometime this afternoon. What's uncertain is maybe the exact time they'll develop, but it's going to be somewhere over northeastern Nebraska on the northwestern edge of the Omaha CWA. So if we go let's look at 22, yeah. So if you go look at 22Z, again, what you see higher updraft helicities, especially with the southern cells. You start to see some upscale growth, and if you go to the 16Z run, it really grows upscale very rapidly. And if we go to 17Z, again, fairly rapid upscale growth to a more linear. 18Z and 19Z, I think, is a little, even that's upscale to some extent. And 20Z, it still hasn't produced any convection at all. So let's look at 23Z quickly. This will be the last one. And if we look at the helicity again, you see for the 15Z run, it keeps everything fairly north of I-80 or the Platte River right here. It still has supercells in there. It has become a little bit more of a linear complex than earlier. We look at 16Z, you see it's a much larger area, so very quick upscale growth. Most of the stronger updraft helicities are in southeastern Nebraska by this time. So it's actually showing weakening over the north. And we go to 17Z, it's a similar picture to 16Z. 18Z shows weakening, and 19Z shows convection there, and 20Z finally shows a supercell developing in the northeast. So it has CI a little bit later. But I think kind of what you get out of this may not be exactly the time, but supercells developing is pretty high confidence. Your environment looks good. You've got strong shear, good cave. You've got a strong boundary to focus lift upon, and you've got and then the HER kind of supports that hypothesis by showing every model producing convection and supercells. The question will be is how fast does this grow upscale over time? Is it going to happen in an hour or two as some of those runs occur? It's going to take longer. And if you look at later runs that we don't have time to do this, the 20Z, it does grow upscale, but it's not until after 0Z on the 17th. So the last thing we'll look at is the visible here. And we'll just do a loop here. And the first thing that comes out is
this is 5-minute imagery.
Oh yeah, thanks. Yes. One thing, there was no measured domain here, so this is all 5-minute imagery, not 1-minute imagery. The one thing I want to point out that's really obvious is the shear shows up beautifully on here. You can see the low clouds south of O'Neill moving northeastward. You can see the mid clouds over Sioux City, east of Sioux City. They're moving almost due east. And then you see the high cirrus moving southeast. So if you were doubting the shear, this kind of really shows it. The next thing you notice is the cluster of QE that starts out west of O'Neill and moves northeast there, and how it is already starting to grow, intensify. Those updrafts are getting stronger, kind of what Ariel talked about yesterday. We can't see any orphan anvils. The cirrus make it very difficult to really see if there's any orphan anvils with those storms. But you can tell that you're getting pretty close to convective initiation by the time this loop ends at 20Z or 1957Z. And so what that would tell me looking at this loop is that probably the delay that the 20Z HER shows probably a little bit too slow. Because you're probably within an hour of convective initiation, maybe within 30 minutes here of it. So that's kind of the outlook or environment.
Yeah, and when Phil and I talk, these are all things that you most likely would be doing anyway, with or without radar, but it probably, just highlights you need to be even more environmentally aware, without radar.
Yeah, if you know you're without radar, the environment is really going to set up your expectations.
Okay, and as a reminder to folks on the phone or that are here, go ahead and submit questions, comments for Phil in Slido. I guess let's go locally here first, based on what Phil has shown so far. Questions, comments on the environment to this point.
Use that bad one. Anyone have any skills?
You're showing the HER model and then the satellite. I guess the question, we really don't have it in the AWIPS yet, but especially when you're looking at 5-minute data, even 15-minute data for that matter, how useful would it be to get some of this simulated radiance data into AWIPS to have an example of what you're looking at and what the model thinks you're looking at? Because the model may be projecting one field that looks pretty good, but then if you compare it to something else, then you realize that the model really isn't capturing what is going on that you see in the satellite.
I think that'd be really interesting, especially from a farming operating fraction, to see what the radiance values were off of in the model. Maybe it was producing Q, and for some reason it's not developing it very rapidly, or something, or it's not. It would answer those type of questions as well. So I think that would be a value to people to compare like the visible.
So this is 21. This is an hour later than that last satellite image here. So you can see some of these earlier run within an hour. There was a lot of consistency that between 20 and 21Z, you would have CI except for that very last model run. I don't know, Phil, what are your thoughts based on this 20Z satellite image and leading up to that versus that most recent HER run that's really delaying CI potentially?
Yeah, I'd be pretty skeptical of the last run. You just look at that, especially just east of O'Neill there. It looks like it's really about to go within the next 30 to 60 minutes at the most. You can see that. You even see some cloud top cooling with that already. So it's probably already through the cap. So the idea of a delay like the 20Z HER was showing seems extremely unlikely.
Anybody else?
Okay, so we're going to start moving at the 4 o'clock essentially. And SBC issued a severe thunderstorm watch for eastern Nebraska at 3:30, so 30 minutes ago. So you can see, let's why don't you try stepping through it? I think that might be easier.
Sure, and maybe get a little wording with what we have too.
Okay, so in your upper left, you've got the 064, the visible half kilometer with the odds on it as well. Upper right is 10.3 IR with the bars are the bunkers right moving predicted supercell motion as well. In the lower left is the low level water vapor imagery, and in the lower right we have the EM, TLN lightning, total lightning. And that's going to be
perhaps severe as well.
Oh yeah, and perhaps severe, you're right, yeah. And that's going to be really important because you'll see as we go through this, we're going to swap between, especially between cloud type temperatures and lightning, and to some extent also the visible quite a bit, because what we found when Chad and I went through this is you really have to look at all of those together. Isolated by themselves, it's very difficult. So we start at 20, I think it's 2020. Yeah, let's start about 2030. So you can see by 2027, you see the clouds are really cooling just east of O'Neill. There, you can see lightning in those cells already as well. Not a ton of lightning. I forget how much. It's probably about 29. So around 30 to 50 lightning flashes per strike per 5 minutes. You can really see nicely the tops on the storms east of O'Neill and northeast of O'Neill, and well, as it's mapped out in Cedar County as well. And you see the cloud tops have already cooled. I think they're below -50 at this point, if I remember right. So as we move ahead, we'll go ahead 5 to 32. We'll focus in on those storms. You can see the clouds continue to cool pretty rapidly. The lightning does increase a little bit, but not a lot yet. It's still generally between 30 and 50. And as we keep going ahead, we go ahead another 5 minutes. You see the cloud tops continue to cool on both those cells. They're now around -60. Lightning's increased slightly, but again, nothing that would cause you to concern. But what's interesting is you go from 37 to 42. If you look on the northern cell, behind there, if you go back again, and then ahead, you can see that there's a new updraft forming right behind the coldest cloud tops. And that cools at about 8 degrees C in 5 minutes. And as that's happening, you can also see, you'll see the lightning right now is still, I think, right around 12, about 45 strikes in 5 minutes. We'll go ahead another 5 minutes. And you see that the cloud top continues to cool on the northern cells. Now I think -63 or so. And you see that the lightning continues to increase. And the nice thing about the lightning too, which we talk about, is when you start thinking about where the warning's going to be, is the lightning gives you a ground truth of where it is. It takes care of the parallax problem that you're having. So you can see there is an offset of probably about 5 or 10 miles to the south, or the reflected or the satellite imagery is about 5 to 10 miles too farther north than where the actual storm is located at this time. So if we go ahead another 5 minutes, you see that now the lightning's really increased. So we saw the cloud tops cool between about 37 and 47, and then now the lightning, we've got over 100 strikes in 5 minutes. So we've had that lightning jump that Brian was talking about this morning.
And perhaps severe.
Oh yeah,
almost doubles as well.
Yeah, it goes up to 88%. I think it was at 52 before that. It was 49. Yeah, so you see both of those go. So this would be the time where you'd really strongly consider issuing a warning, especially in the environment that we're in, because you know that there's strong enough shear to support supercell development. You've seen a new updraft develop very rapidly, and the lightning increase really rapidly. So at this point would be the time where on that northern cell, you would look at probably issuing a warning for parts of this is Knox County here and to the east-southeast, using both the lightning, how the lightning's moving, and as well as keeping in mind what the bunker storm motion is showing, which is an east-southeast motion at the same time. And if we go ahead to 57, you can see that this pixel right here, I think is 99. So you've got over 200 strikes now. So you've gone from under, I think right around 55 to over 200 strikes in 5 minutes in a 10-minute period. So that's a very strong signal that you want to be issuing a warning at this time. Most likely a severe thunderstorm warning, given the low probability for for tornado, at least from an environmental perspective. Also notice that the western storm here also is starting to see the lightning start to increase, and its prop severe is up to 77. So there's two ways you could do it if you didn't have radar. You could try and combine the two storms together into one warning, or at minimum issue the warning on the northeastern cell, and then be sure to keep an eye on the western cell because you probably will leave a warning in the next 10 or 15 minutes.
So, what about the length of that northern storm warning cell? What would you recommend? A shorter time period based on, not having any radar? Do you have any thoughts?
My usual rule is if I think there's supercells, I usually go 45 minutes. Okay. You could argue for 30 on that initial cell, maybe it's not taking hold, but given how rapidly it developed, I typically would go 45 minutes and thinking that there's a potential that it could be rotating. For hail size, you probably sit there at least 1.5 inches. Again, without radar at all, you're kind of winging it a little bit. You wouldn't want to go quarters, because if you're thinking it's a supercell, you're going to probably be able to pull out larger hail than a quarter-size hail. The hardest thing is obviously the wind, what you would do with wind, because you don't have that type of information available. I did look at ECAPE early on my own. It was around 500 joules per kilogram for down-drop CAPE at that point. So I'd probably mostly focus on hail at this point for that northern storm.
Okay, let's take a couple of questions, comments, go locally first.
Thanks, it's fun to look at. I noticed with the prop severe that the normalized cooling was from 2015, and it looked like that one updraft didn't start building until 2045. Is that the one that Chad is on right now?
Yeah.
So I don't know how that's going to temper your interpretation of prop severe, but that's just one of the things you can look at to compare.
Oh, yeah. It's something I haven't really gotten used to looking at before. We tend to look at the mesh a lot in prop severe and the lightning part of it. So I haven't gotten a feel for the normalized vertical growth rate at all.
Just out of curiosity, in the next readout with Sam and prop severe, there was like much something.
There is diversions in weather service neighborhoods, but you can get it in GR.
Yes.
That is one of the inputs into
That's correct. And which is in this one, but it's just not being sampled. That's correct.
Okay, other questions? Okay.
And this is the earlier just walked in, but you talked about the parallax, and would you like to have a tool in AWIPS that would calculate it?
Yeah, let's reiterate on the parallax.
Yeah, that's a good point, Jim. Parallax is a problem if you're going to try to issue warnings this way. That's why you have to have, I think you have to have the lightning. And I think the big question becomes if we get the GLM, are they going to solve that? It sounds like we're on the way to solving that parallax issue, which is different from the ADI parallax issue. I mean, it would be nice. When I was looking at it yesterday, the one thing I worried about is if it adjusted the parallax on the high clouds, would it end up covering information on the inflow, which is what we're going to look at next time, that you might hide. So like if it shifted the high cloud south, but it doesn't shift the low cloud south, you could lose information on the what's happening on the inflow, what the cumulus feeding into it. Maybe there's a way around that too, but I think there'd be a little bit of a danger with fixing the parallax issue on its own without dealing with what some of the stuff you might miss at low levels.
Yeah, and that's why Phil had prop severe on as well, to kind of give you a guide where that storm is, because that's using MRMS inputs, obviously. I know there's a question up there, did prop severe have radar inputs? It did. Again, this is a proof of concept, and radar was there for Sioux Falls and Omaha, and all that was being included in the prop severe, and potentially, if radar was out, prop severe may be impacted. We also have the Omaha radar here as well, right? So if Sioux Sioux Falls radar was out, and that's the closest proximity radar, you would also have a neighboring radar, most likely. In this case, would be Omaha to help guide you as well.
Yeah, exactly. I think if this were a reality, what we'd probably have up on another screen, you'd have our Sioux Falls radar up in a floor panel to look at.
Yeah.
And then as the storms approach Omaha, you switch to Des Moines radar. But we wanted to make it really hard, fun, whatever, and have it really going on. Just to see how it works.
Comment on that. In this particular area, I think you might be slightly closer to the Sioux Falls radar anyway,
Right.
than the Omaha radar, and I guess it could still impact around severe a little bit, but at least it's different.
Yeah.
Yeah, you're right, Dan. It's really, once you get south of Wayne, Nebraska, I think it gets closer to Omaha. But right now, I think Cedar County and just Sioux Falls radar is slightly better.
Yeah, let me just follow up on that too, because I was thinking total radar denial of coverage. So no MRMS, no prob severe in its current form.
Sure. Then you would have lightning as a guide.
At least you'd have lightning.
Yeah, and that would be, yeah, you'd have to use lightning too, but otherwise you'd really be stuck. Because I don't think anybody, and I couldn't figure out exactly where the storm was, taking into account parallax and all that stuff. It's not possible.
I don't know if Doug Pavlo is listening in, but it would be kind of interesting data from that experiment. Anybody else? All right, let's take a couple of questions here. I think we answered first. Second question, I like the bold gradient colors in your water vapor enhancement. Is that part of the baseline? How does it do with picking correctly?
Water vapor color curves, man. That's a hot topic.
Yeah, isn't this the same?
This is not the default.
No.
Someone's happy out there. Yeah, this is the Sims, I forget what it's called, the name was. Dry yellow, thank you. That is in baseline, yeah.
It's available as a selection.
Yeah.
It's not AWIPS, but it's not the default.
Next question. You operate in a mountain office. Summertime convection is often marginal. Forcing using old satellite data imagery signatures are most influential when you decide not.
I think, my experience, of course, is in the plane, so we get really strong convection there. I would think the biggest thing would be looking at some sort of cloud top cooling combined with lightning data. I mean, if the clouds aren't cooling very quickly, cloud tops aren't cooling very quickly, and you're not really seeing your lightning data just fluctuating amongst the mean with very little change. The storm, I think those two together are a pretty strong indicator that the storm's probably not severe. Now, that's a lot from a hail perspective, probably. I mean, obviously, I know out west you can get high base convection where you get dry microbursts and stuff like that, which I'm not sure. I would have to defer to people out west what the best way to handle that would be in terms of using satellite data only. But I think if your cloud tops aren't cooling very much and aren't excessive, and you're not seeing that would be a big clue right there. That's probably, you're less likely to have a severe storm. I think that's the best way to put it.
Let's take the last question. I think we can talk all about recommendation for products to use for polygon creation. Given the parallax issue, MRMS, grid lightning, etc.
Oh yeah,
Statement on that.
I would definitely, in this case, okay, if you had no rim, I would use the gridded lightning. Because if Chad loops that, you can actually follow the storm. You can create a relative storm motion by focusing on kind of the centroid of where the max lightning is. So you can kind of see there's an east-south-east movement across Knox County there, and you could probably get a crude estimate of the motion even that way. And so that would be my recommendation. Would be to use the gridded lightning. Obviously, if you had MRMS, that's probably even a better way to do it. But if you had no radar whatsoever, the gridded lightning is going to get you pretty close. It's not going to be perfect, but it'll get you pretty close to what you need
for location, and then you have to the regular bunkers for the
speed and the
exactly.
Yeah.
All right, let me jump on that.
Now we're going to move ahead
20 minutes.
So we'll pretend like we issued one warning here, the one for Knox County, the
northern storm.
Yeah, northeastern storm.
So is Knox County the one that we're talking about?
Yeah, that one right there. That chest.
I apologize for not knowing my Nebraska county names.
Well,
Yeah, what's happening?
So, let's see, we've gone at 20 minutes, correct?
yeah.
Okay, good.
So let's see.
I'm going to stop it at 2057. Everything is queued up here.
Okay.
Kind of where we left off. Okay.
Okay. So what we're going to watch now is, since we have the warning out on this storm that Chad's, we're going to now look at this storm to the west, because you should see the lightning was starting to come up at 2157. So one of the things I want to look at here is the visible imagery first. So we're going to step ahead slowly. So you can see all this queue to the southwest of that storm forming. And it's actually getting some vertical development as it begins to move, and it's moving northeast towards our main cell. And so you can start seeing some of these small towers start getting ingested into that storm. So it's a little bit less. Yeah. So watch as they move northward, and you see there's a tower right up here. Oh, go back. Yeah, right in here.
Yeah.
And you can see it. Then you go ahead 5 more minutes. And you see it's obviously been ingested. And if you look at as that is happening, watch how much the cloud top cools on the western storm there. It goes rapidly from around -55 to almost -70 C in 10 minutes, if I remember right.
So we're about low 60s.
Yep. And one thing is I find really interesting watching is you can watch how these updrafts come on behind the coolest top. This updraft forms behind where the coolest cloud top temperatures were, so it's kind of just replacing itself over time. But you can see that rapid cooling there over time. And when we go and look at the lightning, you start seeing a similar response. So go back here, there's 57. So if you go to 02, there's not really a huge change, if I remember right. There's not a huge change in lightning. 61. Go ahead 5 more minutes. And now we see a little bit more, and I think 5 more minutes when it gets its max. Yeah.
Oh, I didn't hit this one. There we go.
102 and just at 8 square kilometer, 8 by 8 kilometer block there. So you're almost over 120. So you see how, as this queue is starting to get ingested in there, it's actually influencing and enhancing the development of that southern cell. And so we see the cooling. The cooling start about 5 minutes. The cloud top cooling start about 5 minutes before we see the lightning response, and then we see the lightning response come in at around 2117, and that would be between 2112 and 2117 would be the time, depending on how confident you are, of issuing a new severe thunderstorm warning. And I think the props severe really jumped there too. Yeah, even before that, 72 to 88. So yeah, even at 2112, with an 88% prop severe and the cloud top already cooling, that's probably a strong signal that you'd want to issue another severe thunderstorm warning.
The southern storm is almost developing quicker than the northern one.
Yeah. Yeah, in fact, we watched the northern one, it's actually gone to a steady state after we issued the warning up there. And its cloud top temperatures are cooler, so you can imagine it's probably a stronger updraft with that southern storm. Probably because it has better, more clean inflow into it over time. So again, you make that decision, then you kind of put your box, your storm right here, and then between the bunkers motion and kind of the motion of the max lightning, you draw your box out to include whatever these two. My Nebraska county knowledge ends at the Missouri River. So these two counties to the south here, I think it's Antelope and Stan, if I remember given that, again, the rapid, that updraft looks very strong. And so, again, with that environment where you're thinking supercells are likely 1.5-inch golf ball size hail would not be missed at all. Again, knowing that you have nothing to look at from a radar perspective, looking for mid-level cores and anything like that.
Okay. Questions locally? All right. Let's take a look up there. I think we did the first one. Let's do the second. So there's the third right now. Radar out, and you were tracking storms using the grid point you created, which you consider you see AWIPS imaging options. Like,
What does that look like? I haven't tried that, so I'm curious how it looks.
I'm going to clean this up a little bit.
Yeah.
Especially the southern racks. That's a nice east-southeast.
Yeah, it's right along the supercell motion back here. Or predicted supercell motion. It's probably not a bad way to go. I think you'd probably want to have, I'd want to have the grid somewhere and then have that for orange ends up on. And if you're wondering why we haven't done the polygons, we couldn't get orange end to work on thin client. So that's why we aren't showing that part of the process.
all right. How much of it do you think of RGB applications, such as data connection, RGB, in conjunction?
You know, I think early on, when you're looking for, you know, glaciation on the storm and such, it would be very useful as you're looking for new storms to develop, new updrafts. I think once you get to this point where you have a fairly mature storm, and you're really concerned about more with cloud top temperature and how that's changing over time, over small time intervals, I think in that case, it becomes a little less useful. I think it's great for new storm development. My experience is limited, so someone can easily argue that there may be a better use than I'm saying.
Yeah.
But I think once you get to this point where you're looking at cloud top temperature, I think it becomes more important to look at the ABI imagery directly.
Yes, it's important to remind everybody that the forecast offices only have the daytime convective RGB on the full disk at 6 kilometers. That's why there's limited use of this most likely.
Anybody else in the audience?
So Phil, I'll ask you a tricky question. So what we do in the wintertime with low tops, severe stuff, with critical lightning, and not much, you know, signature on the IR for full tops.
Yeah, I think being in the north, I don't have to deal with it like you guys do with the south. So I think that would be a much more difficult problem, obviously. You know, I don't think you get the rapid cloud top cooling. Those tops are like 25,000 feet, is that correct, Pete? So you're not going to see that as much unless, you know, not having looked at satellite too much on those type of storms. I think it's almost like you'd have to recalibrate completely, almost do a whole study to see other signals. You know, maybe the clouds cool from -20 to -25 or something on the strongest updrafts, but I think it would be more difficult to use it in that situation for sure. Usually, there's usually a lot of cloud cover around, if I remember right, in those situations. So you'd be looking for kind of almost like a needle in a haystack type thing. And I wonder in that case, if there might be RGBs one could develop to help you out there too.
Okay.
Yeah, one more. We're going to go ahead. moving ahead about an hour. Yeah, let's slowly walk through it. But let's just run the loop on the eye, because I think the IR is really cool in this case. It kind of brings up some of the stuff Chauncey pointed out yesterday. You can really see as these updrafts go, you can see these warm wakes form around here with each updraft. You get one there and one there. And also the thing to really notice is you can watch the northern updraft go back to the beginning. You see this northern updraft, and then a new updraft forms kind of in between the two cells. And that's where you get this really cold cloud top. I think it's over below minus 70 there. And so, it's one of the things where I saw this live in real time, and my staff and I were wondering, what's happening on radar? We really like to know how the radar evolution looks like with this stuff, because I think there's a lot that we could learn by looking at how these thermal couplets evolve over time, and maybe get more information on how the structure of the storm is changing or the updraft is changing over time. I'm sure there's been some work on that, and maybe like Scott or someone has more information, or Dan has more information on that. But I think there's a lot going on here in terms of these warm couplets, and you can at times you almost can see it kind of move out of way. These warm waves move out of way almost like a gravity wave, which someone mentioned this morning as well. So I just these are very really get a sense of how intense these storms are, because you keep these updrafts just pulse up, and you see the warm waves form, and then they'll die down, and you get another pulse up on these storms. So I just kind of wanted to point that out a little bit. So if we go back to the 4 panel, this is where meso-analysis can be really good. This is something Chad and I really looked at. If you watch the visible, let's do it like this. So let's step ahead one at a time. And we'll watch the visible, and you watch the overshooting top strip, but also watch the orbit at Wayne, Nebraska, which is right here. Okay. So as we move ahead, you can see the really strong overshooting top on that southwestern storm. But notice that as we go towards swing 2Z, Wayne's wind is on to the east more. And that would actually should be a big concern, because that may mean there's a local enhancement in the helicity there as the wind's back in this area. And you can also see this is the 0 to 1 helicity in the purple. And so you've got a 100 0 to 1 helicity in storm relative helicity in that same area. But that backing wind, that should wave a flag that you may have to start thinking about a tornado warning. Again, pretty nerve-wracking when you don't have radar. But it's a marginal environment, so it's certainly not the first go-to thing, but it's one of those things that there's a boundary here. You see the backing of the wind, and you starting to see an increase in storm relative helicity with that cell. And you still continue to see very good cooling at cloud top there as well. And you also, I think at this scan here, I think this is over 100 flight feet. Just in that one pixel, if I remember right. Oh, 100 exactly. So I think there's a lot. At this point, you really start wondering, do you need to start considering a tornado warning. And obviously, what you ideally would want to do is call spotters and stuff like that. But I think this supercell has been around or moving for over an hour now. So you can start getting more organized. You can start getting an RFD surge or something like that as the storm continues to organize. And with it going near a boundary like that, and you can see that it's still on the boundary to the cold front here there too, that you may have a local enhancement in helicity in that area as well on that storm.
Yeah, and this overshooting top means quasi-stationary for a good almost 10 minutes. And it seems to suggest that robust updraft.
Yeah, and I think the other thing you can notice too is the helicity is based off the bunker storm motion. If you watch the lightning, the storm motion has actually gone to the right of that motion as well. Because these lightning is now moving almost at due southeast. It's not no longer south-southeast direction or east-southeast direction. So actually maybe even some more local enhancement going on. That's not there as well. So, obviously what you want to do is you want to look at, get reports. But I think, the duration of this storm, the fact that the wind, you can see the difference between Norfolk here, due south, east at Wayne, Nebraska, really gives you a sense it's a pretty good boundary that can locally enhance the helicity and maybe allow you to develop a tornado in what is a fairly marginal tornado environment in terms of just 0 to 1 shear that we looked at earlier as well. Yeah, you have to make sure that it's better southeastward motion. So, we talked about, we did it, I think, Chad, you're thinking was the eastern cell there would be the one that.
Yeah, well, I think the question you asked me, and we can ask the audience, I think before we went into the analysis, we were wondering if one of these would have a higher tornado risk than another. I didn't know the answer. Phil obviously looked at it, and based on quasi-stationary, based on, the thing that really stuck out to me was just how back the winds were. So why don't we tell everyone kind of what happened?
Yeah, so actually, I'll just make sure I got it right. There's one weak tornado at 2147. That was in Pierce County, which I think is that county where your hero is. But that was just a brief tornado. It was on your ground for a minute. The big tornado was at 532, and that was with the eastern north cell, the one that.
This one?
Yeah, it was with that one.
Which is about 30 minutes after.
Yeah,
this kind of
and that was on the border of Wayne and Stanton County, which I think is in here somewhere.
Probably.
Yeah, that was an EF1. That was EF1 tornado damage to farm set. It's on the ground for 5 minutes as well. There was also, there was also golf ball size hail with both of these storms as well, and you also had strong winds eventually at the Norfolk ASOS, which is right here at just before 6 o'clock. Eventually, for those who may not, this was actually this was I think a $1 billion damage event, because eventually it evolves into a line in Boeco that just southeast goes through Omaha, produces 80 to 100 mile an hour winds in the city of Omaha, and then a tornado just south of Omaha in one of the southern suburbs, I think Bellevue, if I'm not positive there. Eventually makes it all the way to Kansas City before it dies. In fact, if you were here for it was Ariel's talk, the MCS that he was showing at the end was this storm cluster. So that was it was a pretty major severe weather event. And I think just to close this up, as this is obviously a worst case scenario, no brainer whatsoever. So the idea here would be to at least get some warnings out. You wouldn't be able to necessarily make the correct tornado warning or whatever necessarily. You could try your best. You may not be able to pick out, it was a QLCS tornado near Omaha. That's going to be very difficult to pick out, just obviously, well, very difficult. It's almost impossible to pick out on radar, on satellite. You need radar for that. But at least you'd be aware of the potential and could issue warnings. But I think what this really says for us is that we were using 5-minute data here. Can you imagine what we could have seen with 1-minute data? I mean, the detail in the evolution could have been much more interesting. A lot of the ingestion of that cue to the south would have been much more easy to see. And so I think it really shows the need for offices, anytime there's a slight risk or greater, is to request a mesodomain in their CWA so they get 1-minute data during severe weather operations. I think we've seen it here. We saw Chauncey show it too, and we saw Jenny show it this morning. It's just there's so much information there from a severe weather operations perspective. And then a combination of meso-analysis, satellite lighting can provide a means to issue warnings, even in the absence of nearby radar data. Again, is it going to be perfect? Is it going to be as good as a warning where you have radar? Obviously not. But at least you can provide people some warning so they can take shelter. And I would add that this is essentially a type of meso-analysis that you're doing. You're just doing it at a much more detailed level than what you do. But this is what we should be doing every day in our office when there's severe weather, using the lightning data, the satellite data, to inform us on what type of warnings we want to put out off of what we're seeing on radar. And then identification of new and enhanced updrafts with rapid cloud type cooling and thermal couplets, I think, is a strong signal for severe weather. It's something that I'm hoping to look a lot more into because it really struck me on this case. So that's all I've got. Thanks.
All right, let's take a couple of questions. I think first of all, let's address the NDS issue real quick. This is actually part of the here's a two-part comment / question. Where were the mesos this day? So 1 minute. I think.
So this was June 16, which means we can't quickly go back and look because meso requests started maybe a week or two later than that. I don't remember exactly where they were.
I'm trying to find out, but at this time our process was an RSO that we requested, and we were able to move the meso. We weren't using it for any tests, and we moved it to where RSO was placed. It's possible to do testing this day when it's available.
I guess the follow-up to that is, in terms of the ranking order for NDS requests, is there anything in there about equipment outages? So in other words,
Oh yeah, I did that.
FO has a radar outage. They happen to be in a place where they have no TWR. So you pick that higher on the list of requests.
Yeah, so in the latest update, we had noted that in 35 for TSS request authority. So there's a radar outage that they're putting right impact of the situation. Everything again up to 30 minutes later.
Okay, so it's at number 5, TSS.
The MDS sectors were on holiday and Baja. That's
Yeah,
right.
that was a scan.
It was 30-second. They're both over.
Oh, it's 30 seconds.
Yeah, it was, yes.
So the first mistake, so you can remember it is.
No,
Okay.
I'm trying to remember that. That was a test we ran a couple of times.
Okay. There appears, I'm going to jump down again, we'll go back to the one topic. There appears to be signals of an above anvil plume visible at our larvae channel to an indication of rapid mass evacuation down the ocean bottom. Unsure to what extent these correlate with severe. It seems a lot more like those.
Yeah, that's actually something, Chad, you brought up with us at Northern Sioux. We had Northern Sioux workshop, and Chad spoke to us. And on the 17th of June, there is, you see that with the 3.9, if I remember correctly.
Yeah.
You can see the rapid mass evacuation. And we didn't look at it in this case. You can.
mean, you can somewhat see very, very thin cirrus. There's not a ton here. Not as evident as some, that are very obvious. You can see it right there. There's obviously an above-annual cirrus plume at the very end. Not a lot of reflection in the 3-9 where you maybe expect it. Definitely.
Other questions from the audience here? Let's go. Pat, Dan.
So Phil, this is a great presentation. I appreciate you doing this. One comment and one thing that I want to throw open for discussion. One is on those worm couplets, I see that those are also reflected in the water vapor imagery. So it appears that there's not only some significant warming there, but also apparently a little bit of drying. So I'd be really interested in any future research on what's going on with those. The thing that I want to throw open as a question and maybe some discussion is the topic of messaging in this situation, where you're going to be issuing warnings that maybe are going to have to be a bit bigger than you might otherwise issue, maybe with a little less precision than you would have with radar. What, if anything, do you do or do you think should be done with messaging that? Is that something that you let partners in the public know? Hey, our radar decided to go in the tank today and we're working hard to get it back up, but we're issuing warnings without our radar right now. Or, what do you do with that?
This is just a quick thought on it. I would definitely work with my partners. And the reason I would tell my partners is because I would use that and say, hey, we really need your help. We need your help. Our warnings, we don't have radar. Our warnings are probably going to be bigger than we normally are. We'll probably be a little more vague, or vague is probably the wrong word, but the hail and wind takes may not be quite as precise as normal, but we really need your help getting reports. If you can get us reports, that can make up for a lot of what we're not seeing with radar. And to be honest, depending upon your relationship with your TV partners, you might even say something in 12 NWS chat to them as well. In Sioux Falls, we have a pretty good relationship, so I would be comfortable saying, hey, we're without radar. They would know anyway. We're without radar. We're issuing without radar. So if you guys hear reports, please let us know. Now, there was also one station that has their own radar, so they would probably take advantage to help themselves. But I think I think if you're open with them, I don't think I'd go out to the general public and tell them, because I don't think they understand quite how that's working and what we're trying to do. But I think with EM partners and with media, I would be open with them and say, because I think you try and leverage that to try and get them to help you out, get you the information that you need, especially EMs. And a lot of REMs, I think, would be more than willing to try and make up for that.
I think you also want to emphasize surrounding radars. Oh, yeah, we're not having, right? You're not completely radar. You may have upstream.
Yeah, great presentation, Phil. First of all, I totally agree with your assessment about the meso analyst. I think that's a great. I think every office should, if they can, and have a person to do it, to sit down and take a look at the visible imagery, and maybe sitting beside the person who has the radar imagery as it's actually issuing the warning to be able to talk back and forth. The other question is one that's really impossible to answer because you already know the answer. But so say in this situation that you did not have radar and therefore did not have the full troposphere capability, and you saw the inferred location of that boundary based on the surface odds and the strength of the storms, would you have issued a tornado warning?
That's a really good question. I'm biased being extremely conservative on my warnings. I hate false alarms on them. I don't know if, I'll be honest, I don't know if I would have. What I've done is I would have called the EM in Wayne County, whatever county that, kind of back and say, hey, we're seeing a very strong storm here. We're seeing a front. Could you have someone go out there and see if there's any type of fog cloud or rock cloud with it? Now, if the shear's 25, 30 knots instead of 1 there, then I'm probably leaning towards issuing a tornado warning. At around 15 knots, I'm probably a little bit more leery of doing that, so I'd probably take a miss on it. But to be perfectly honest, I'd be curious what other people would do who have radar experience as well.
So Matt's question kind of beat me to the punch, but I'll follow it up with maybe a little bit of a joke, but a partially serious question too. So at what point does somebody become old enough to change the text in their warning from National Weather Service radar indicated to National Weather Service satellite indicated?
That's been done in Puerto Rico. I mean, AWIPS, right?
Yeah, I think you have it. Yeah.
That's the first time I ever saw it done.
Okay, should we take one? Yeah. Anybody else? Last chance verbal question.
I think there are plenty of towns right now out west that have almost no radar coverage. I'm thinking especially in the Four Corners region, Durango and Cortez, big populations and almost nothing there. So I think this kind of guidance is extremely useful even now with our full radar coverage. And not only that, but I give a shout out to OPC and so forth from right here. They're getting more interested in offshore support. So I think it's really important to do more research on comparing the signatures between radar and the other sensors, for those cases when there is data denial and you can't access everything that you have. Even if your radar's up, it's going to be useful for quite a few people. So I really like where you're going on this bill. Hopefully, some more of us can do the same.
Thanks. Yeah, thank you, Jen. Yeah, I agree. Going back to Dan's question earlier, I think if we're able to do more research and relate what we're seeing on satellite to what we're seeing on radar, maybe my reluctance to issue TOR would change based on different signatures. But I think there is such a volume of research that can be done here on this data. It'll take years, to probably catch up on it. It's kind of like lightning in that sense. I think we're just starting to really get into how much lightning can really help us. And I think that GOES-16 is going to be the same way. I think a year from now, 2 years from now, we're going to know so much more about how the relationship between what we see here and what's happening below the anvil.
Okay, and with that, let's give Phil a round of applause. Thank you.